Hi, today I'm going to show you how to use the PDB Debugger that's built into Kubetorch to debug a distributed training and also an inference application. Typically, this kind of debugging is available to you when you're working locally or on a devbox, but the goal of Kubetorch is to allow you to produce production-ready applications at scale without sacrificing any of the debuggability or iteration features that you would have working at a small-scale environment like a devbox. Here I have a training loop, so we'll start with the distributed training. This is just a toy training example. This is our hello world. And down here, I'm going to use Kubetorch to launch it on Kubernetes with 4 replicas. Obviously, you can get 4 GPUs on one node, but we're going to launch 4 nodes with 1 GPU each to represent the distributed training. And in the training, I can simply add a breakpoint like so. And I'm actually just going to add this breakpoint onto my first rank. And I'm going to go ahead and run this. So, because I already ran this training earlier, my pods are warm, and Kubetorch allows for warm restarts. What's going to happen here is that when I call the remote function, it starts the training again. You can see that the ranks initialize, and I can see that a PDB debugger has started at my breakpoint. And all I have to do is to take this command, paste it in here, and it launches the debugger. So, you know, I can progress, I can interact with this as you would expect. You can run commands, and you can progress, and as I go, you can see that after I hit the end of the first epoch and print, my training has also progressed, and you can see that it has gone. And now all 4 ranks have finished the first epoch, and you know, I can do more interactive work here, and then when I'm happy with it, I can continue, and the rest of my training will go ahead and run. Now that the training is complete, I can tear down the debugging session and make changes to my code, and any changes to my code that I make would instantly propagate on the next iteration. I can now also show you how to do it with an inference application. You can see here that I've defined some decorators for my llama model class. You don't have to use the decorator pattern. You can use the exact same .to pattern that we use in the training example, but sometimes folks find the decorator pattern more intuitive. To deploy the llama model to remote compute, we simply call kt deploy. And once again, I already have this service up, so redeploying that service and iteration is nearly instant. In order to use the debugger here, I can simply, in the call to inference, add the field PDB equals to true. So I can just start a session anywhere. This doesn't even need to be on the machine that launched it. I can start this debugging from anywhere. So my inference could have been deployed by CI and live as a service on Kubernetes. And then if I import Kubetorch, if I import my llama model with Kubetorch, because I've decorated it, I can simply make a call. And what will happen is that will go directly to my remote service and generate on the server. And it comes back, and I guess it's a little bit verbose. But now if I want to call the same inference with the debugger in place, I can simply call with the argument PDB equals true, and now go back here, and you can see that I am now in my inference service, and I have the debugger available, and once again I can now run my debugging commands, especially if there's something up with my inference service, I can just go and directly call into that remote inference service that has been deployed to Kubernetes from my local environment and do the debugging there. I can go ahead and continue, and you can see that as I go, it will start processing the prompts, and I can finish this off. The goal of the debugger is that now you have access to the same powerful tools that you would use for local development, but now you're running at scale, building proper services or building proper distributed trainings without having to go and do it locally, make sure it works, and then spend a week or two translating that to a production environment where you don't have access to the same kind of interactive development and debugging.